Hello and welcome to my math channel. My name is Kevin. I'm currently a junior in high school and I hope to one day become a math teacher. I'm very passionate about mathematics. On this channel I hope to work through a few example problems, maybe get a few concepts across that maybe some people don't understand, and really just have fun problem solving and working my way through difficult problems, showing you my thought process. So here's this episode I'm going to be using problems from Wocomal.org. I may use some different sources in the future, however, that's going to be kind of the main, what I'm going to do for now. Right now I'm doing an arithmetic problem. I'm actually going to do three of them, a 1 point, a 2 point, and a 3 point, so increasing difficulty. This is the easiest one. So if you want to pause the video now and give this problem a try, kind of go along with the video, and then see my thought process, now would be the time to do so, because I'm going to jump right in right about now. Okay, so what is this problem asking? Always the first question you should ask yourself. They're really, they often try to get across a concept. They're not just trying to get the problem. So you can see here we have a power to a power. So they want to know, can you do a power to a power, and can you multiply these exponents of the same base together? Keeping in mind that Wocomal is a math competition, so they are trying to dig out the best in you, and they are trying to see if you understand these basic concepts. So we'll start with the numerator. This squaring actually kind of carries over. So it's 2 squared times 10 to the 5th squared. 2 squared is 4. And 10 to the 5th squared isn't quite as easy for most people. It can look a little bit strange, but you have to think about it logically, and when you do, it's pretty clear. 10 to the 5th is 10 times 10 times 10 times 10 times 10. And when you square something, you multiply it by itself. So it really is as simple as saying multiplied by 10 times 10 times 10 times 10 times 10. And so here, you could probably see we have 10 to the 10. Counting up these tens and just knowing what an exponent is. But a shortcut to do that, if you didn't, if you already understand this concept, is you can just multiply these two together and you get 10 to the 10. So the numerator is 4 times 10 to the 10. Now, for the denominator, first we're going to multiply these two together, the 8 and the 5, and we're going to get 40. And then it gets a little bit tricky, because we have 10 to the minus 3 times 10 to the 12. When you're multiplying exponents of the same bases, you add them together. So minus 3 plus 12 is 9. So we end up with 40 times 10 to the 9. But I'm going to slow down and kind of show you why we add when we have a common base. Alright, so 10 to the minus 3. It's a little bit of a more difficult concept to wrap your head around than, say, 10 to the 3. But really all it's saying is 1 over 10 times 10 times 10. And we know that 10 to the 12 is 10 times 10, blah, blah, blah. 12 times. So if we multiply those together, we get 10 times 10, 12 times, over 10 times 10 times 10. And this is going to cancel out 1 for each of those 3. And we're going to be left with 9 tens, or 10 to the 9th power. You might already see the correlation between the numerator and the denominator. However, if it's not quite so obvious, you can move the decimal over here, divide this side by 10, and multiply by 10 over here. Because technically it is one big number, because they're multiplying together. So dividing 10 over here and multiplying 10 over here, it's still the same value, it's just written a little bit differently. And we end up with actually 4 times 10 to the 10, which is exactly what we had on our numerator. And as most of you know, when the numerator and the denominator are equal, the answer is 1. There's the first problem. Alright, so moving on to something a little bit more difficult, we're going to do the 2-point problem. the 2-point arithmetic problem for that meet. As you can see, a star b equals a squared b, and a triangle b is a plus 1 over b. And then we have an expression. We want to evaluate it when a and b equal a certain value. If you want to copy that down and want to start doing it along with me, or pause the video and do it and see what my explanation of it is afterwards, that would be the time to do so, because I'm going to jump in right now. Alright, so our immediate goal is we want to get this into terms that we can understand a lot better. This a star b triangle b star a. And that's not super difficult to do, actually, surprisingly. This a star b, as we can see right up here, is a squared b. So the second, you might jump into the second one and say, well, that's also a squared b. But the problem with that is that it isn't necessarily. You can see that order might matter in this star operation. And the first term is the squared term, and the second term is left over afterwards. So as weird as it is, you are plugging in b for a and a for b. So you actually end up with b squared a. And yeah. So now we have to figure out what this triangle means for these two expressions, because these are officially in expressions that we can calculate with. Also keeping in mind that you're not allowed a calculator during the Wocomal competition, so you're not going to see any super number crunching problems. A lot of it's going to be pretty basic arithmetic. Alright, so we see that the first term is a in the triangle, in the definition of this triangle problem. And it's adding more stuff on. A is alone, so we can just take a squared b and add the rest. And the rest is just 1 over the second term, b. So we have over here 1 over b squared a. Alright, so now it's time to start plugging in values, because we have something that it has squares, it has fractions, it has things that we can understand. There's none of that fancy triangle or star nonsense. So, a is 2, so I'm going to start off here. 2 squared times 1 over 3 plus 1 over 3 squared times a. So 2 squared is 4 times 1/3 is 4 over 3 plus, when you square a fraction, you square the numerator and the denominator. It doesn't particularly matter in this one because you're squaring 1, so it's just going to be 1. Anyway, so we have 1 over 3 squared, which is 9, times 2. So that's 2 over 9. And this 1 over, whenever you see 1 over a fraction, you can just take that fraction on the bottom and flip it. So because it's 1 over this fraction, we can just say that this is 9 over 2. So it's 4 over 3 plus 9 over 2. So simple addition of fractions. Most of you probably get that, so I'm going to kind of blast right through it. So you multiply both these terms by 2. You get 6 with an 8 on top. Plus, you multiply both these terms by 3. You get a 27 and a 6. And then once you add those up, you get 35. Not super difficult math. Like I said, there's no calculator, so I mean you're going to be doing these in your head, and you have a time limit. So 35 over 6 is your answer, or 5 5/6. Alright, and lastly we have the 3-point problem from the same round of the arithmetic. And as we can see right here, hard is some binary operator. And we need to figure out what it is in order to figure out 12 hard 4. Or at least it may seem that way initially, but we never quite have a definition. Or I never quite had a definition for heart when I had found my answer. So if you want to work your way through the problem, it's a fairly difficult one, but yeah, if you think you can handle it, then go ahead. All right, so first I'm going to take a look at these 3 truths. These 3 things that they gave us and they told us are 100% of the time true. X heart 0 is always going to be X. X heart Y is going to equal Y heart X. Essentially, order doesn't matter. And this last one is a lot trickier, actually. It took me a while to understand it, but essentially what it's saying is if you cover this side, let's say you have X heart Y. If you increment that X by 1, it is the same as saying that normal expression X heart Y plus 1 more than Y. So, I'm going to start off by using 2. That second truth that they gave us. And I'm going to rewrite this as 4 heart 12. Just for the sake of making it a lot easier. So from 3, we know that 4 is 3 plus 1. So if we had plugged 3 in here and 12 for Y, this would be equal to this expression. So this also has to be equal to this expression when X is 3 and 12 is Y. So we can just plug that right in. 3 heart 12 plus 13, or 12 plus 1. And that's really the method to go about essentially the rest of the problem. Is say this 3 heart 12 is the same as saying 2 heart 12 plus 2 times 13. Because now we're still plugging in 12 for Y. But we're adding another 13. So we can just say 2 times 13. And we're going to do it again. So then we have 1 heart 12 plus 3 heart 13. And you can kind of see the pattern. And at this point, I mean, I don't have to keep explaining each one. You could just kind of see that this will go down 1 and this number will go up 1. 12 plus 4 times 13. And we know that because order doesn't matter, X heart Y is the same as Y heart X. So up here we can use this first identity. And we can say that this in here is equal to 12. So now we have 12 plus 4 times 13. Using PEMDAS, we know that we have to do the 4 times 13 first. 4 times 13. I'm actually going to do it out because I don't have it in my notes. 4 times 13, that's 12. 4, 5, 52. 12 plus 52. I already know the answer, but I'm writing it out. 64. So that's our final answer.